All right, so section 8.4, we get into special properties of, or describing properties of special quadrilaterals. So you can see from the title, we're going to cover rhombuses, rectangles, and squares. So a rhombus is a parallelogram with 4 congruent sides. A rectangle is a parallelogram with 4 right angles. And a square is also a parallelogram with 4 congruent sides and 4 right angles. And I'm going to abbreviate this as RT. So right angles. Okay, and then we have a picture for each. So a rhombus. Let's call this rhombus A, B, C, and D. So a rhombus has, first of all, it's a parallelogram. Next, we know that it has 4 congruent sides. So that's what makes a rhombus, the 4 congruent sides. And just so you know, since it's a parallelogram, the opposite angles have to be congruent. So that'll be a picture of a rhombus. And just to point out, the most important thing about a rhombus is that the 4 sides are all congruent. A square has 4 right angles and 4 congruent sides. That's what a square would look like. All sides are the same and all angles are right angles. Lastly, a new shape is a rectangle. So in a rectangle, we have 4 right angles. And the opposite sides are congruent like any other parallelogram. So if this is a rectangle, that means there's 4 right angles. That's it. Rectangle is 4 right angles. Rhombus is 4 congruent sides. And a square is right angles and congruent sides. So example 1 says, for any rhombus RSTV, decide whether the statement is always true or sometimes true. And then draw a sketch and explain your reasoning. So for A, if we draw a picture of RSTV, they want to know, is angle S always congruent to angle V or sometimes? And this would be always. And the reason being, it's a p-gram, or it's a parallelogram. Again, because it's a rhombus. So the opposite angles are congruent. So it's a parallelogram, so the opposite angles are congruent. S and V are opposite from each other. Part B, RSTV, and we'll know, will angle T always or sometimes be congruent to angle V? And this is going to be sometimes, because they're not opposite angles. So the only opposite angles have to be congruent in a parallelogram. These are not opposite angles. So they might be congruent, but we don't know for sure. So that one will be sometimes. And actually, if we go even further with that, the only time they will be congruent is when they are right angles. Okay, example 2, classify the special quadrilateral, explain your reasoning. So in this one, what we see is the 4 sides are all marked congruent. So this would be a rhombus. And the reason being, all 4 sides are congruent. And that would be the reason why it has to be a rhombus. Checkpoint 1, for any square CDEF, is it always or sometimes true that CD is congruent to DE. Explain your reasoning. So if we have a square, C, D, E, F. Squares have right angles and 4 congruent sides. So this would be always, because all 4 sides are congruent in squares. So that'd be always. No matter what sides there, they have to be congruent because in a square, all 4 sides are always the same. And then number 2, a quadrilateral has 4 congruent sides and 4 congruent angles. Classify the quadrilateral. So 4 congruent sides, 4 congruent angles would be a square. I mean, it's also a parallelogram, and it's also a rectangle, and it's also a rhombus. But the most specific name would be a square. So we go with the most specific name. All right. Theorem 811 says a parallelogram is a rhombus if and only if its diagonals are perpendicular. So in this picture, let's call this A, B, C, D. So it is a parallelogram, they're saying. So this would be A, B, C, D is a rhombus if and only if these 2 diagonals are perpendicular. So if and only if segment AC is perpendicular to segment DB. So in a rhombus, the diagonals are perpendicular. Theorem 812 says a parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. So in the picture again, we'll call it A, B, C, D. So it is a parallelogram. And what makes this a parallelogram is parallelograms have to bisect the opposite angle. So like segment DB bisects angle B and angle D, and segment AC would cut these angles into 2 equal parts, or cut them in half. So ABCD is a rhombus if and only if segment DB bisects angle ABC and angle ADC, and if segment AC bisects angle DAB and angle BCD. And theorem 8.13 says a parallelogram is a rectangle if and only if its diagonals are congruent. So we have A, B, C, D. And it is a parallelogram, so the opposite sides must be parallel. So it says A, B, C, D is a rectangle if and only if AC, so from A to C, is congruent to BD. So segment AC must be congruent to segment BD. And that would look like this. All 4 parts of those diagonals would have to be congruent because they're equal to each other. So that means each part would have to be the same because they also must bisect each other because it's a parallelogram. Okay, example 3. Sketch a rhombus FGHJ. List everything you know about it. So we're going to sketch it. FGHJ. A rhombus has 4 congruent sides. Let me fix this. So what we know is it's a parallelogram. By definition, a parallelogram has opposite sides congruent, so this is a parallelogram. So what that means is the opposite sides are congruent. The opposite angles are congruent. The consecutive sides are supplementary. This is kind of... And lastly, the diagonals bisect each other. So since it's a parallelogram, we know those four things. The opposite sides are congruent, the opposite angles are congruent, the consecutive angles are supplementary, and the diagonals bisect each other. We also know, specific to a rhombus, is that four congruent sides are a part of a rhombus. And we know the diagonals are perpendicular. And we know the diagonals bisect opposite angles. So that's everything we know about a rhombus. If you need to pause, go ahead and pause so you can get all this written down. And then example 4 is saying, you're building a frame for painting. The measurements of the frame are given. The frame needs to be a rectangle. Give the measurements in the diagram, or given the measurements in the diagram, can you assume that it is a rectangle? So in this one, we see that the opposites are congruent, right? 20 and 20, 16 and 16. But in order to be a rectangle, what do we have to know? We have to know that those are right angles. We don't know that they're right angles, so the answer is no. Need to verify for right angles. So we don't know for sure, so we can't just say, oh, it looks like a rectangle, it's got to be a rectangle. And then part B, if you measure the diagonals of the frame and they are about 25.6 inches, what can you conclude? So if we do a diagonal like this, and we get a right triangle, what we would have is about 25.6, we would have 20, and we would have 16. So can we verify that this is a right angle? I know I put the box there already. And it says that the measures, sorry, I misread that. It says the measures of the diagonals are both 25.6 degrees. So can we say it's a rectangle? Yes, it's a rectangle. And the reason why is because it says the diagonals are both 25.6. So we would say the diagonals are congruent. So what I thought of doing is doing Pythagorean theorem to make sure it's a right angle, but we don't have to because they tell us the diagonals are congruent. So this way is quicker. And lastly, sketch rectangle WXYZ and list everything you know about it. So let's sketch a rectangle that has four right angles and the opposite sides are congruent. W, X, Y, and Z. So it is a parallelogram. So since it's a parallelogram, we know the opposite sides are congruent and the opposite angles are congruent. The consecutive angles are supplementary. And the diagonals bisect each other. So all of these are true because it's a parallelogram. And then things specific to a rectangle are the diagonals are congruent, And lastly, there are 4 right angles. All right, so definitely more specific than a parallelogram because we got a little more to it, but everything from a parallelogram still is true about all these rectangles and rhombuses and squares.